Today we are here to talk about the data science program at UMA led by Dr. Matt Doobie. So we are very excited to welcome him here tonight, speaking with all of you. We'll get a little bit of background about the program, the ways that you can kind of connect this to any major field of study, and what the hiring marketplace looks like for students who have credentials for this program. In addition to that, if you happen to be talking to people and kind of come across them and you think that they might be interested in this information, you're always welcome to have them contact Matt, myself, or Haley Brown, and we can email them the recording of this session as well. But for the sake of time, we're going to go ahead and kick it off, pass it over to Dr. Doobie, who will take us on a journey all about data science this evening. Thank you, everyone, for being here.
We don't need the pretense of the title. My name's Matt. People know me as that. That's fine. So I'm going to share my screen to start here. I'm going to have to get my slides started. And yes, you see a Mad Lib. We'll get to that in a minute. Actually, a lot of minutes. We'll get to that. But I'm going to start there, and I'll pin myself and do that. So you see all these equations and all of that. Some of those are derivatives. That E equals MC squared thing is a famous equation. It's all math. It's a lot of Greek to a lot of people. And the idea of data science obviously going to have something to do with math. But at the same time, I want to make sure that people understand that data science and data itself is really a part of life today in a way that it never really was before. And we're going to see a lot of how that applies to various things. I'll let Katie and Haley deal with the people admitting. But what we're going to do is really think about, we're going to think about what it means to the world today. We'll think about different programs and why they look that way. We'll think about the job market, and I'll take you on a journey of how different fields might use it, and also the very different places that looking at data has taken me as a professional. And I think that from that perspective, I don't do that to say, oh, wow, look at what this person's done. I do that to say the things that I've applied data to are very numerous, and you can see that they have very much not to do with one another, at least in their subject matter, but at the same time, they have certain things underneath them. So let's do that. So that's me. That's me in my native environment. I deal with maps all the time. Those are specifically voting maps. I deal with redistricting as a concept. So how the people get to Congress, I deal with that. My background is in essentially math and geography. So my titles, whatever. But generally speaking, I deal with how stats and space meet together. I also deal with stats and time and how they interplay with one another. So I deal with math and how it relates to spaces generally. And that can take you in all kinds of different directions. We're going to see that as we go. But at the end of the day, what I would probably call myself is a spatial data scientist. Spatial temporal data scientist, so someone who deals with locations and timing, but also deals with data using the scientific method. But we're not here to talk about me. We're here to talk about a field. We're here to talk about data science as a whole. And that's an interesting term because it's one of those things you hear in the modern world. You probably think to yourself, well, what the heck's that? Right? And you wouldn't be alone. So the whole concept of that has, I would say, a longer history than most people expect. But generally speaking, I think people equate this with one thing, and I'm going to try to break that as much as I can, even though it is an important thing. So we're going to take a journey here to kind of understand what this is and kind of relate it to other things. So I want to start off with what is data science? Well, it has two words in it, data and science. So data, on the one hand, data means what is given. So I'm somebody who likes to look at origins of words and whatnot. Data is a word that means what is given. So that should be sort of indicative of a lot of things. So you might think about, things that you can get from a picture, things that you can get from, say, devices in your home, things that you can get from your phone, things that are in, say, your health records, maybe things that help forecast the weather. So these are all things that we measure somehow. They're all things that we collect somehow. Measuring usually makes us think of numbers, but they don't have to be numbers. So collection is a little more broad than that. But data are things that are given. Science is a word I don't think a lot of people know where that comes from either. Science comes from the Latin word scire, S-C-I-R-E, meaning to know. So if you take the two of them together, we can see that essentially data science is trying to know from what is given, right? Essentially what we can think of this as. But I think it's important to mention the scientific method, because the scientific method has a lot to do with how we think about the utility of data generally. People have some sort of problem they're studying, they do some research on it, they come up with an educated guess of how they think it's going to work. It's a hypothesis. Hypothesis actually means foundation. We talk about an experiment. So we design an experiment that targets the hypothesis. That experiment derives data. That data is then analyzed, and then we come to a conclusion about our hypothesis that might change our problem statement, all of that stuff. So the whole idea of data science combines the two. So we're talking about things that we have, and then doing some sort of scientific method reasoning on it, right? So the difference is between just the general scientific method, because the scientific method has data in it, of course, is that you might envision someone as a practicing scientist start to take data that's been collected for something else. Remember that data is collected from an experiment that targets a hypothesis. They might take data and apply that to some other hypothesis, right? Or some other problem. And when you start doing that, you run into problems. You run into, does this actually apply or not? So that led to a whole problem of how the modern scientific community views things like data mining. That's another term you've probably heard of before, or machine learning. That's another one you probably heard of, or AI. Those are things you might have heard of that sort of get caught in this. But at the same time, the sciences are evolving to recognize the utility of this, and also to sort of understand as a practitioner that you can't just use that method to make conclusions. You've got to then use that method to derive the next experiment, sort of thing. So data science is a long, sort of complicated process. And we can really think about data science as sort of a bunch of pillars holding up something, right? So I think of data science with sort of four pillars behind it. So one is this idea of, and this graphic that somebody else made has two things twisted, which I don't know how they made that mistake. The first one's domain knowledge. So I think that this is what catches most people's eye about data science is data science we tend to think of coming from the business world. I think it comes more from the social sciences, actually, and I'll talk about that. But we think about the domain that's underneath the decision we're going to make. So let's say you're a teacher and you want to figure out, what's leading to my students' performance, or what's leading to my students' lack of performance, or something like that. Knowing something about how people are taught, also knowing things about personal behaviors, right, may have a lot of insight to solving that problem. However, where data science comes in is we start talking about things like, well, there's some math behind this. So there's statistics that we have to deal with. There's rates of change, that's calculus. There's linear combinations of multi-dimensional spaces. If I'm going over your head, I'm sorry. It's just a general concept. We have to deal with some math principles, and those math principles then are met with systems, technological systems, that are able to account for that. So things like algorithms, things like databases that store that stuff. Algorithms work with processes, programming languages, encapsulate algorithms, all that stuff. But the thing that I think most people forget about data science and I think most people actually forget this about science, which is interesting, is the concept of communication. You cannot, and I repeat, cannot be a data scientist without having skills in communication. So data visualization, data representation is probably the most forward piece of data science that you see in the world today. So if you go to social media right now, you will find an infographic somewhere that came from somebody combining data and putting it in some sort of graphic form. Why do we do that? We do that because graphics are easier for people to understand. Anybody's ever looked at a wall of numbers for any more than 10 seconds has had a headache, right? That doesn't have the same effect when you look at a visual. Visual sort of digests that, and we all sort of speak the same visual language if we can see. By that token, we have to think about how to make those further accessible. But at the same time, we can't separate these concepts from that. We can't separate these concepts of analysis from communication. And it's often the step that's missing from the scientific method is the 7th step, which is communication. So UMA has a bachelor's and post-bachelor's degree in data science. UMA has a data science minor and a machine learning minor. Has a certificate in data science. It has a graduate certificate in data visualization, which is in conjunction with the art department. And the University of Maine system also has a data science and engineering master's degree. My master's and PhD are in spatial information science and engineering. They come from the same department at UMaine. Our data science program has a 4+1 arrangement, essentially an accelerated master's with those programs. So you take your 4 years of your data science degree, and some of those courses then apply into your master's degree at Orono in that case. So you can end up with 2 degrees in 5 years if you're following the schedule of the, I don't want to say typical student, but the expected student historically. That's not necessarily the case all the time, but our program is built around these 4 pillars. So students take an outside concentration as part of their data science major. So it might be in business, it might be in biology, it might be in social sciences, it might be in criminal justice, could be all kinds of different things. They take a lot of computer science coursework that motivates data. So things like databases, data structures, algorithms, that sort of stuff. They take a bunch of math courses ranging from statistics courses to linear algebra, calculus, discrete mathematics, that sort of stuff. And they take a bunch of courses that have to do with communication. So you'll take a technical writing course, which a lot of programs take anyway, but you'll also take a course in data visualization. And that sort of combines with courses in like querying data and data mining, which then go to support those visualizations. So all in all, the vision of data science as a program at UMA relates to this idea that it's truly an interdisciplinary field. It crosses a lot of boundaries, and I think that's some of the exciting piece of it, is that you can literally apply these things to everywhere. So there's been some questions that have been asked prior to this. I'm going to address some of them as we go. But what I will say is that I know somebody asked about the medical field, somebody asked about business fields. I know there's some business students here. I tend to focus more on processes than I do with the actual application, because the actual application can be limiting in a sense, because you might not see the pattern that makes multiple situations share something, and that shared thing is their process. So I am going to talk about specific things tonight, but at the same time, I want you to remember that these things that we're talking about in a specific form do not necessarily play out that way as that being the only thing that could happen in that sense. So the question that was very appealed to me when I saw it was, how does data science benefit society? Well, I'm an academic, so I have to say that. But at the same time, one of the things that I think we forget is that the degrees that we get are ultimately philosophies, and philosophies are ways of knowing. They're ways of thinking about the world. So when we start talking about that, we have to start talking about, well, what does the philosophy of data science contribute to society? And I want to leave you with this idea before we get into what we're going to talk about, is that no matter where you go, no matter what you do, data science has an impact on that right now, and it's going to have much more of an impact on that tomorrow and the next day and the next day after that. So I don't think that so one of the things that people may have heard me say before, if you've met me, is that literacy today, we think of literacy as reading and writing. Literacy also needs to include things about being able to comprehend that which you read and write. And today more than ever, that means that you have to have some literacy in and around data and stats and things like that. So no matter where you go, no matter what you do, data science is going to impact that. And if you think you can challenge that, go ahead, because I got a bunch of them. I can tell you that English is impacted by this. I can tell you that social work can be impacted by this. I can tell you that history can be impacted by this. That's a fun one. So there's all kinds of different ways that we can think about this. But where most people's heads go is business. And the reason for this is that the way that we see data today is very forward with companies, right? You think about companies like Amazon, you think about a company like Google, you think about a company like Netflix, for instance. You think about sports leagues; those are big businesses. These are all things that have data at their sort of heart in some sense. And a lot of terms that we use in data science come from that. But I think it's important to recognize that data science has a history before that. So what business did was that business grew data science into public consciousness. So if you think about everything you see in modern businesses today, you couldn't do that without something like data science. So recommender systems. So you go to Netflix, Amazon, something like that, search for one thing, it gives you other suggestions. That happens because of algorithms behind the scenes that are leveraging the whole sort of network of data that these companies have, that based on what you've viewed, what you've watched, what you've purchased, and then suggest other things from that relate to other customers and the decisions they made. Things like targeted advertising. So Target had something that was in the news a while ago where they sent out targeted circular advertisements. You've all seen these sorts of things in the mail before. A lot of times they're not targeted. So like a mom and pop general store, grocery store, something like that might send everybody in their town a flyer of, oh, these are things that are on sale. Target did that, but Target did that around a certain set of products that were meant to target people who they believed were pregnant. So Target collected the data they had from people that they knew were pregnant or not, and looked at purchasing history. And then you had people who started to purchase some of the things on that list, and then they wanted to advertise things like bassinets and cribs and things like this to them. And all of a sudden they're living in a home where somebody didn't know they were pregnant. Uh-oh. Right? So now you can start to see that this task has some influence on some things and can do some kind of ugly things if you want. But something I want to point out is that marketing as a whole is actually a hybrid offshoot of two disciplines, economics and sociology. Sociology has a lot to do with data science because of demography. Something like dashboarding. Dashboarding, you wouldn't have that without art and communication. Dashboarding takes multiple visuals that are built off the same data set, allows you to potentially dynamically play with them, and they change on the fly. So dashboarding has revolutionized how we make decisions in many contexts, most appropriately in businesses, but can be done in any number of things. But as a function of this, a lot of terms we see in the data science world come straight from business. So the one that sticks out to me is something like the term business rules in a database. So a business rule would refer to something that impacts the environment that the database is in. Just saying business rules makes you think that this has to be for money. Well, there are several databases, more so than not, that have nothing to do with a business at all, right? So the US Census comes to mind. The US Census is not a business. The US Census is a record keeping operation. So why does that have business rules? Why wouldn't you use something like organization rules or environment rules or something like that? But no, business rules is a term that's used because a lot of the early data science innovations come from a company that's known for business, IBM. And I say that because Edgar Codd founded the relational database, worked at IBM. Another person, I forget his name off the top of my hand, I think his name is Woodward, created the barcode. Those two things came out around about the same time, and they solved a huge problem in the grocery store sector about people waiting in line all the time for somebody to punch in prices in a cash register. You don't have to do that anymore. So that's another way things have impacted your life, is that you don't have to wait in line in a grocery store all hours of the night because there's a bunch of people in front of you with big orders. They can just slide the products across the scanner, picks it up, bang, on your way. But data science existed before businesses, right? Data science existed and that's because science has evolved and science is evolving, right? So the dirty word to a scientist is belief. So you think about being able to try to make some explanation of something that you can't really demonstrate. So you think about how people would have explained lightning. So the Greeks explained that by Zeus hurling thunderbolts at people that didn't like, or people being bad, right? You think about the pharaohs in Egypt talking about guiding the sun through the underworld because the sun set in the west. Like, where the heck did that go, right? That's a little different. Experimentation requires, of course, stats. Theory, Einstein would do thought experiments. So a lot of the E equals MC squared business, there's no way that you could demonstrate that physically, but the math would show it from some of Newton's work. Simulation, this is actually what this picture is about. This picture is the heat expansion of the universe, which is a simulation of data sets. So that actually leads to the Big Bang Theory. And then data-driven science, you might think about what data scientists would do. This shows a series of conflicts historically, and those conflicts come at how people come to know things. So this is why it's taken a while for data science, though the technologies have been around, for things like the sciences to sort of accept those and leverage them in different ways. I think it's helpful to know that because of the whole idea of what the scientific method represents. So I mentioned things like simulation. People do simulation work in data science all the time. They are taking derived inputs and they're shoving them at these simulators, and these simulators then produce what happens if, right? That's all stuff that's based on modeling. But the question was, how does it impact society? So some of you may have seen this painting before. If anybody's been to the US Capitol, you've probably seen this painting. It's a painting of Abraham Lincoln, who's in the center left of this image. It's pretty recognizable, has a staved-in face. Got the sort of neck beard thing going on. People know exactly who that is when they see him. But this is Lincoln reading the Emancipation Proclamation to his cabinet for the first time. And if you look in the bottom right of that picture, you see something. And you may not have noticed it before. There's a map right there. That map is a product of demography. So demography being the study of people, essentially. So what you're trying to do is figure out different statistical characteristics of populations and recording where those things are and whatnot. So that is really the first graduated color chloropleth map. So mapping has something to do with data science, but that map was instrumental to the Emancipation Proclamation. So if you know your history of the Civil War and you look at that map real close, you can see the scars in the map of Sherman's March to the Sea. You can see where the largest amount of fighting was in the U.S. Civil War, which is in Virginia. you can see those spots, right? And those spots have to do with a strategy, right? The strategy is to upset civil unrest, right? Which makes it harder for the South to wage the war, right? But at the same time, it's the place you could destroy their economy, right? So this map has a lot to do with actually the Emancipation Proclamation being passed, right? Or being issued. I shouldn't say passed because it was Lincoln could do it without Congress, right? But the idea being that understanding the aggregated features of that map, this is population density of enslaved peoples, that had a lot to do with the Emancipation Proclamation coming to be. So that is a huge social impact, and you may not have known that. But it impacts society today in a lot of different ways. You maybe don't even think about it. So it's probably easier for you to do a lot of different things today. And some of those things you probably don't even realize. So one of those things is you can talk to a device and it turns your lights on, right? Well, it has to process your voice into some sort of signal, and it has to recognize you want to actually turn the light on, right? That's data science. The barcode scanner is data science. It's a sensor. It's a technology that links into databases. That's clearly data science. There's lots of different things that you probably don't even recognize that has something to do with that. You probably see things that you're more likely interested in today than you did before. And that's not always a good thing. So you think about social media gives credence to things that it expects you're going to interact with because it wants to be a useful service, right? So that's how they get more and more data as you interact with more and more things. So that can create echo chambers. It's been leveraged in all kinds of different political campaigns, most famously starting with Obama, leveraged a lot of social media and younger generations to become president. But also later on, many of you probably heard of Cambridge Analytica having some sort of interaction with the 2016 election, that sort of stuff. So these sorts of things aren't always good. You probably have a much better handle on a lot of social problems. And as a society, I say that because we've had much more data collection, much more focus on things like intersectionality of things, maybe using different analytical techniques in different places we never used them before. I've been involved in that. You probably have a lot better access to scientific knowledge today. And that's because of data visualization. So you can see the results of some of these scientific studies distilled into images that portray the data, right? So that foundationally changes how we understand the world around us. It's probably easier to derive scientific hypotheses today, even if they're incorrect. And that's because of data mining, because this gives us the opportunity to explore things we wouldn't have thought, because data mining is looking for patterns you don't necessarily see. So why did I start with that question? So whether you know it or not, your future job is going to need data science one way or another. And there's, of course, a corollary to that, that a data scientist can get almost any job they want because the skill set is marketable across the board. And how do I know that? I know that because one of the things you see in a job market combined with the education sector is you'll see that when something is really novel and something is really growing in importance, you see everybody and their mother create a graduate degree in that field. Well, that's exactly what's happening with data science, is you're seeing data science degrees pop up all over the place, right? And that's because it's important to the modern economy. So that's something to be aware of. Now, what I will say is that it's really hard to do a data science master's. And it's not because you're not capable. It's because there's such a wide array of what data science represents that it would be impossible to get sufficient depth in all of it for that to be eminently, worth it in that sense. I'm not saying don't take a master's in data science. By no means I'm not saying that. What I'm saying is you need to temper your expectation about that. When you look at an undergraduate degree in data science, you have a lot more coursework that you take that gets you a lot deeper into certain things so that you can understand them, versus what graduate degrees are designed to do is literally dive headlong into like 10 topics throughout your experience. And in data science, there's just way more than 10 topics that you would need to be fluent in. So it's easier to, in that sense, have a data science degree and then tack on something to it versus having some other degree and tacking data science onto it, because there's this math problem that's sitting behind it too. So why is it beneficial to society? I like to come back to this type of image. This is Ackoff's pyramid. It explains the process from data at the bottom as a foundation to wisdom at the top, which is making good decisions. So what data science's job is to take us from that foundation of that pyramid up to wisdom. So different aspects of data science will fit into this pyramid in different ways. So you'd imagine something like querying data. SQL is a language. You'd imagine that influencing data going to information, because information is adding some sort of context, some sort of meaning, categorization, that sort of stuff. Versus visualization might try to take us from the information side up to the knowledge side. Versus sensors are on the bottom part of this, right? So the other part of this is something like a decision support system, which would take us from the knowledge up to the wisdom. So it doesn't tell us the answer. It makes us have different views of what the answer could be. And then we have to use our noggins to create to collect the one that's the best situation here. Okay. So I show that to contextualize probably the biggest contribution of the business world into data mining, which is a sort of philosophy and procedure for applying analysis, right? Applying data mining is how they'd phrase it. CRISP-DM, cross industry standard protocol. So what you have is the CRISP-DM process, which goes from understanding the problem, understanding the data, cleaning the data, prepping it, exploring that data, trying to create models, validating those models, and then presenting them. That sounds an awful lot like the scientific method in some sense. Not a surprise. What is the surprise is that if I ask somebody on the side of the street who's heard that term data science and what they think that is, they're going to look at step 4, 5, and 6 more likely than they are step 1, 2, and 3. The day in the life of a data scientist looks an awful lot like steps 1, 2, and 3, more so than 4, 5, and 6, because 60 to 70%, maybe even more than that, of a data scientist's time is spent to the left side of that line, versus maybe 20 to 40% is on the right side of that line. So that's something that might challenge your views of things. Now, you can then think about, well, how does that impact the world? Right? How does that impact the world? We have to spend all this time cleaning. Why do we have to spend all this time cleaning? We have to do that because data comes in different forms. We're going to talk about that. But imagine if we could shore up that side of the house and what we could do with it in steps 4, 5, and 6, right? That's part of the challenge that we have as a society, is we have to have better protocols and standards for data coming into systems. So if I translate that back to that pyramid, I've put the dividing line now between data and information, and I'm saying that 60 to 70% of the labor of a data scientist is below that line. The other 30 to 40% are above that line. And that's sort of the rebalancing of this pyramid is one of the things I think is going to be things that happen as we get better and better at leveraging data. So this is sort of the future, kind of thinking about how we can alter this image a bit. So why do we have this problem? Why do we have to spend 60 to 70% of our time before that line? It's because of big data. Big data is another one of those terms you've heard. People think about big data, there being a lot of it, and that's true. But big data has other problems with it associated with it itself that are just as important. So things like the variety of data sources. I work with maps. Imagine having a map that comes from a drone or a satellite flying overhead. This is now a picture, it's an image, right? So it's like a camera took it. Imagine then having some sort of vectorized object, like you might find, say, the state of Maine, for instance, state of New Hampshire, town of Augusta, town of Solon, where I was born, that sort of stuff. Those two types of data files don't mix, right? You could then have somebody else who's referring to on their 140 characters of fury, Twitter, that stuff, right? You could have somebody refer to the same location but not have a picture of it. How do I know I'm talking about the same thing, right? So that variety is very important. Velocity, how fast it's coming at me. I can have infinite data storage, but if I can't solve the velocity problem, I can't really leverage that data well enough. If I'm getting data too fast and it takes me time to process it, the decision is now outdated, right? Now, we can think about that in the scope of seconds. We can think about that in the scope of months and years. And often social problems have solutions that are reactionary that take too long to actually get to them. So that's sort of the velocity issue. We have veracity issues. So can I believe that, right? Then we have validity issues. Validity issues have to do with, is that plausible, right? I would say those four things are way more important than how much of it there is, because those things can lead to bad decisions, right? Or they can lead to making decisions more difficult, right? So this is kind of instructive, I think, to understanding why so much time is spent before that line. I think it's important when you ask the question, what does the day in a life look like, that you understand why the day in a life might look that way. So people asked about medicine. As I said, I try to avoid that as much as possible because it can be awfully limiting. I will do this, but I want you to be thinking as I do it, and I'll also do it with business simultaneously. I want you to think about what's beyond this. I want you to think about the patterns that exist that make these the same situations. This is called abstractions. These are called abstraction. So being able to see them for their pattern, not for what they are. And for what it's worth, the things I'm going to mention here are actually real applications. They aren't made up things. So first one I want to start with is cancer. So some people may be quite familiar with cancer. They may have had a loved one that suffered with it. They may be a survivor of cancer, but medical diagnosis is a critical thing, right? So some concepts, however, might be difficult to measure. So it might be difficult to measure just by looking at a cell, whether or not that cell represented a benign tumor or whether it represented a malignant tumor. So there were some data scientists and biologists that got together and took images of today is used as a foundational step in the process of diagnosing something like breast cancer. So
Matt,
yeah.
I don't know if it happened for everybody else, but I experienced you freezing there, so you might need to go back and repeat from the beginning.
Did I break up or something?
Yes. Yeah.
Yep. I think we got to the point where you said that the biologist and the data scientist got together. And then we kind of lost you after that.
I know I got a list that my internet connection was unstable. Can somebody acknowledge they can hear me?
Yep.
Haley, Katie, can you hear me?
Yep. Can we hear you? Can you hear us?
You garble to me, Haley. I get a choppy. So
Okay.
all right, great.
yeah.
I see that I can be heard. I just heard something before, thought somebody had a question. So okay. So this same premise here, the same premise of it's hard to measure certain things. Let's see if we can find a way to classify them. And then we can use that classification to look at future cases. That whole concept also shows up. It's the exact concept I mentioned about the pregnancy situation. where you had Target figured out from all of the data that it had that this person's likely pregnant. So I'm going to send this person targeted advertising about pregnant products, right? So imagine if that's how your family found out you were pregnant. Imagine if you were hiding that from somebody as a surprise, right? So you wanted to surprise the person who you're having a child with, and you wanted to have a nice moment about that, and all of a sudden you have the circular show up. Like, wait a minute, right? It takes away a lot of things, but this is the targeted advertising piece is the same idea as trying to predict that cell is benign or malignant. Bayes' theorem. This is something that relates probabilities of events and probabilities of events given other events. This is something that actually saved our butts a few years ago. So when the pandemic started, it'd be awfully hard to know what the rate of people having COVID was, right? The best way you'd have to deal with that is to have everybody get tested, right? But that's impractical. And then you have things like wastewater that might be able to help you and that sort of thing. But Bayes' theorem is built to take 4 probabilities and put them together. And if you know 3 of them, you can derive the 4th. So essentially, you get a system of equations here that can actually figure out the rate of COVID in the population, which is something that is enormously helpful in trying to manage a pandemic. But Bayes' theorem also shows up in business too. Think about insurance companies. Insurance companies want to think about things like acts of God. They want to figure out, is it likely or is it more likely or not there's going to be a flood here, maybe a hurricane, maybe an earthquake, tornado, something like that. Certain things are eminently predictable. Certain things are not, right? And if you start thinking about the predictability, you might want to go a different route in terms of how you handle it. Epidemiology. So if anybody's ever heard of cholera or maybe experienced cholera, I should hope you haven't experienced cholera, but if you have, not a fun day, not a fun however much time it's going to take. But cholera is an interesting disease in history because it's a disease that people thought transmitted in a way that it doesn't. So cholera transmits via water, but people thought it transmitted via air. So there was this anesthesiologist called John Snow. John Snow was living in London in the 1850s. There was a cholera outbreak. So Snow, as a scientist, went out and about and tried to figure out, well, where are people dying of cholera? And this is the map that he produced. This map shows quite clearly that the deaths are all around that red dot. That's a pump. That's the Broad Street pump. The people at the time thought this was an airborne disease. It's not. It's a waterborne disease. Snow's the one that figured this out. So the way he figured it out was there were some anomalies in the data set. There were a couple people who were from a few blocks away that died of cholera too. But the reason that they died was that they got water from that pump. There were people who just had a taste for the water at that pump, so they had their children go and get them water. So their children literally killed their parents, not because they wanted to, but it happened, right? But that was how we figured out that cholera was not an airborne disease, right? This is some of the beginnings of what would be my actual graduate field. Heartbeats. These are cycles, right? So you could imagine searching data for cyclicity. So things are just repeating. So think about heart murmurs. I have a heart murmur. The way you might find that is you see some different pattern in the heartbeat, right? Or somebody having an irregular heartbeat, same idea, right? Stethoscope helps with that, but it's nothing like a time series to show you a pattern, right? This leads to things like event detection. That then is used in engineering for different things. That's used in businesses because you think about what's on the shelves right now. You find a bunch of Halloween candy. You're gonna buy caramel. You're gonna buy candy corn in May? Probably not. You're gonna buy candy corn in March? Probably not. right? But you will buy it now. So there's sort of a cyclicity to products that sell on shelves, right? So we find candy corn on the shelves this time of year, find jack-o'-lantern buckets this time of year, find fun-sized Skittles, M&Ms, that sort of stuff, whole massive aisles of candy, right? But in other times of the year, they replace that with something else because they're more likely to sell, right? So we could also think about that in many contexts. So that's a temporal version of that. Imagine that you did it in space. Imagine that you had people going to restaurants, you know, those digital Coke dispensers that allow you to put flavor shots into them. That sort of thing was used actually to develop patterns for what types of flavorings are people putting in their drinks. Because then Coke offered cherry Sprite because they found that lots of people were doing that all over the country, right? But what if you had a regional taste? What if you saw that this type of flavoring was being put in that drink in New England? You'd market that product in New England, but not anywhere else because you can sell it, right? So this is another sort of data science thing and turns into product development. Something like Watson. People might be familiar with Watson or Deep Blue because Deep Blue beat Gary Kasparov, Grandmaster in chess. But really what Watson's about is leveraging information. So what IBM was trying to do with Watson was actually to put Watson in places where it was important to make the right decision. So today you'll see doctors will use things like Watson to have the insights of every doctor who's ever lived at their fingertips. So you see these symptoms, you can search for that and you can find diagnoses and different patient data and all this sort of stuff. Doctors are smart, but what's better than having one doctor? How about having thousands of doctors being able to look at the same case and not even have to contribute their time to it, right? That's the power that something like artificial intelligence has. The same premise is used in chat bots, right? So you may be interacting with a chat bot and you wouldn't even know it because what the chat bot's doing is actually taking what you're asking and it's thinking about, well, how would somebody respond to that? But also what is my data about my situation tell me would be what that person needs to know. So that chat bot is the exact same idea as what Watson is. And that's used in businesses all the time. Watson is also used in businesses as well. So we've seen different forms of this. Maybe we don't even recognize it when we're doing it with a web version. Phone ones are obvious, but that whole thing is all about working with a knowledge base. Geospatial lifelines. So as somebody in my background, this is an important concept. People's memories are fallible, but if you could imagine somebody wearing something to track their location and their time, seems like surveillance. But if you could imagine that happening, imagine what it would mean for a doctor. Imagine what it would mean for a doctor if I could monitor where you've been and how that's relatable to maybe the symptoms that you have now. So what if there was a radiation event and you didn't know about it, that you ended up in that area, right? That might impact your health. Or that a disease transmission, that a disease can sit on a surface and then somebody could touch that surface and contract the disease, right? These sorts of things are much harder to deal with in memories because you maybe don't know that, right? So geospatial lifeline is that concept. And this may seem like science fiction, but your phone's got a GPS in it. That's important because it allows for this to happen. If you wanted it to happen, you could use that to your advantage. That's not to say people do this. It's to say that you could, right? And that actually plays out into business as well. It plays out into business with something called the physical internet. I have a friend of mine from grad school who's a professor at Maine Maritime Academy, focuses his work on logistics and essentially trying to assemble products closer to their destinations. So in effect, taking different parts of products, treating them as packets like in the internet and moving them along networks. And essentially what we've got to do is get things to be in the same place at the same time so they can be assembled and moved along, right? That's exactly the lifeline procedure. So I want to emphasize again, this is about abstraction, right? These were a few different ways that data science is used today in the medical world, also in the business world. but they have similarities between them immediately, right? Every one of the things I just showed you could have been a different scenario in precisely the same exact way. So image recognition, fingerprint scanners, Bayes' theorem is used to detect spam in your email. Point mapping, I do work in housing insecurity. Temporal patterns are the basis for statistical process control, which saves companies millions of dollars, right? Artificial intelligence, ChatGPT, anyone? Geospatial lifeline, think about emergency services. Anybody seen the commercials for the Apple Watch that have someone who has a heart attack while hiking? And they're able to figure that out, and they know where to find them because the watch has the ability to get the pulse, has the ability to know the location, right? There's way more to these things than just the examples I've shown you. So I want to transition now into thinking about the job market. So we're here to talk of Benjamins, right? So data science is a lucrative career, right? I'll show you some common data science jobs, but I need to exercise some full disclosure here. Maine is different. Maine is different in salary range. We'll talk about that a little bit. It's not huge, but it's different in salary range. But at the same time, Maine is different because Maine's economy is not built in the way that, say, California's economy is built in terms of the sector itself. So we'll talk about this generally. It's going to relate back to my journey itself. So here's some common job titles that a data scientist would hold if you were talking about something like ONET or something like that. So data scientist, data analyst, data architect, data engineer, business analyst, data developer, chief analytics officer, chief data officer, an actuary, machine learning engineer, statistician, database administrator, data storyteller. That sounds fun. It actually is very fun. Analytics engineer, data visualizer, software developer, database designer, process control engineer. These are things that data scientists do. If you were looking for the specific job title, these are the types of things you look for. But I want to take a more data scientist feel to this, because I could just say average salaries, whatever. These are the two distributions of data scientist salaries in Maine on the top and the United States on the bottom. So Maine is about 8,000 behind in the data science market on the median. What I find, what I tend to get people to focus on, is why I said I want to look at this more like a data scientist, is I want to focus on the bottom of that distribution. So the idea of the 10 percentile, which is the lowermost dot that they put here. So that 10% of data scientists in Maine make less than something, and in the US make less than something, is important because that probably reflects things that are closer to like starting salaries, right? Because these are everybody. This is not tied to experience level. This is literally your job title is data scientist, what you making, right? So, and this is kind of consistent actually with myself. I'm a data scientist. I don't have that exact job title, but when I was hired to my job right now, right, my starting salary was pretty much that 10% right there. My salary now is much closer to that mid-career situation in the 96 area, right? So that sort of plays out for myself. It plays out for a PhD student that I had. He actually ended up commanding 100K starting salary in a private data science firm. So there's all kinds of different ways that this plays out, but that's just the job title. Database administrator was much of the same, it's a little less. It's comparable. Floor effects about the same. The difference here in the job market that we need to understand is the explosive factor in job availability. So of all the sectors in the economy, right, the hottest sector in the economy is the tech industry, right? Because you have all these different product developments, right? You have all these different technologies coming to bear. Database administrators have been around a while. That's growing at like 5 to 8%. That's pretty good growth. But data scientists are growing closer to 25, 35% in job availability, right? That's a good area to get into. right? Because there's going to be plenty of work, right? Statisticians. This is a much different curve in Maine, right? This is not a common job title in Maine. So statisticians look roughly the same nationally as data scientists and database administrators, but in Maine, it's very different. This is also rapidly growing because sometimes this is synonymous with the data scientists sort of idea. People think about the path through the career. So one of the things that I want to mention is to kind of put some of these numbers in context. The average annual salary in the US is about 60,000. So this at minimum is about 15% higher if you look at the smallest one. The smallest one here is data analyst. This is probably the typical starting point in a data science career. So what we have here as an image is a bunch of credentials. So we have the bachelor's degree in a computer science or relevant quantitative field. We have a master's degree in that same type of field. We have a PhD in that same type of field. And then we have business, finance, similar degrees to that, and humanities degrees. So when you look at this, this is a series of data science careers. The arrows are the ones that matter. The dashed lines in the middle are different things that might be at the same level of an organization, but just gives you a sort of idea. So the typical starting job for somebody who goes through a data science, computer science type program and wants to get in this field is data analysts, probably make somewhere around 70K. A data analyst may then graduate into going in the sort of systems route. So things like a database administrator, someone who does modeling, someone who does software, someone who creates new data, someone who looks at the structure of data, then becoming the data scientist, which is using all of the sorts of tools together. So you'll see that title data scientist on average doubles the salary from the data analyst, but there's a lot more that's involved with that. That might then lead to things like a machine learning engineer or a research scientist in computing. Those are things that are typically tied to things like PhDs. But generally the pathway is from data analyst to data scientist through some intermediary step. The other direction is to think about the ones who aren't coming with those sorts of degrees. They might end up as somebody who's a business analyst or a marketing scientist or something like that. And then that might then move into the data science realm. So similar sorts of starting points salary-wise from the data analyst and the business analyst. The business analyst is oftentimes a lot more private sector types of things, so it can offer a lot more, that sort of thing. So this is sort of a branching of how these jobs sort of relate to one another. But I said Maine was different. Maine's job market is very different, at least for now. Because if you think about the types of companies in Maine, we don't have a lot of companies that might hire a data scientist directly or have a position that says, oh, data scientist, right? So I can think of a few. Unum, an insurance company, they might hire an actuary, it'd be the same idea. A company like Garmin, a company like LL Bean, right? A company like the colleges and universities might do that. Different governmental agencies might do that. Right, but the pickings for that are far and fewer between, right? But what I will say is that data science is a flexible skill set. It allows you to apply it to any position you could find yourself in. Everybody needs problem solvers. Everybody needs people who can make sense of things that they have. And the benefit of this is that you can truly find something you love, because you don't necessarily end up at a data firm that all they do is contract out and work on separate problems. They actually go to work in an issue that they care about, and then that issue that they care about has data issues, right? That can be hugely beneficial for your sort of morale, if you think about it, is you can make it so that you actually understand the domain you're working with far better than you would as a consultant. So that can be good for you. Now, that's not to say this is what the job market in Maine will forever be, right? Because as the data sector grows, the job titles for data scientists are going to grow in Maine, right? That's just it's a natural thing. Maine's just a little behind economically with that. So if you want to be a data scientist, what are the types of things you should learn about? Well, you need to have a handle on statistics. You need to have a handle on programming. You should be exposed to data mining or machine learning, which essentially is a combination of those two things. Data cleaning, can't emphasize that enough. And I'm actually offering a topics course this spring about data cleaning if people are interested in that. Data visualization. I teach a course in data visualization in the spring. It's a fun course. It's challenging, but it is fun. Databases, database design, database management, stuff like that. SQL, can't emphasize that one enough. Software developers, if there's any computer science students around here. Software developers who want jobs, typically line item requirement on their application is, do you know SQL? Right? It's over half. Over half of all job postings require that in that field. Logic, so being able to reason through logical fallacies and what's correct logically. And the other thing I would say is interdisciplinarity, being able to understand different thought processes and apply different thought processes for what they're worth, right? That is extremely important for anybody in the computing field, but especially for data students. For the computing folks that are here, get the question, what languages should people learn? Just like the medical discussion, the business discussion, not a huge fan of that either, because languages change all the time. The issue is algorithms. But what I want to show you is something that sort of speaks to this, which is the rankings of languages by how they relate to job postings. So I'm going to stop sharing that and then move over to this. So this is from the IEEE. So this is the top programming languages in 2023. Python and SQL are at the top, which is what the expectation, I think, is what most people would have. But old languages shouldn't be forgotten. So what we have in here is a dashboard. Go figure. This is top programming languages 2023. Spectrum is the IEEE communication thing. So that's not the company that does cable and whatnot and had a spat with Disney. It's not that company. But you can see that Python here is the highest ranked of the programming languages. Then Java, SQL is right there. If you look at jobs, this is really interesting. The jobs ranking puts SQL first. This shows you how important it is, right? SQL, Python, Java. R's down there. R is an open source, crowdsourced language. This is used in a lot of science fields. So that is growing in importance. You can think about what's trending. R moves up a little bit. Python's moving up. SQL is a little higher. So these are different. This is just programming languages broadly. If we think about popularity of programming languages, which is about their movement, you can see that Python has the largest popularity share, but then there are other languages that are related to data science, such as Swift and Rust, that are moving up, and Julia, that are moving up the rankings. Okay. So essentially these are trading people. Python and Java have exchanged about 5% over the years recently. Let me go back to this. And I want to reemphasize, programming is an algorithmic process. It's not a syntactical process. You can learn any syntax you want, but that does you zero good if you can't solve the problem you're trying to code first, right? In that skill of problem solving and algorithmic development, that's transferable. It's the same skill you use to cook. It's the same skill you use to do teachable art. And the difference between somebody who doesn't have those skills and me is the creativity piece that might make the cook a chef and might make the teachable artist, or the teachable art person, an artist. It's like you start to see how the pieces go together and you can make them play off of one another. So that's more the advanced degree training side that I bring to the table, is that sort of stuff. Somebody will ask the question, is data science for me? So these are the types of things you want to be comfortable with if you want to get into that field. You want to be comfortable with quantitative skills. Math is important. No matter what people want to think, math is important. And a lot of times people's comfort with quantitative skills was diminished because of how they were taught when they were younger. So one of the things I urge you to try to get through and get over is this idea that you can't do math. The parts of math that you need to be responsible for are the sort of pattern sides of math, not the computation side of math. We have tools that do that. It's important to know the order of operations because it's going to impact how your calculation comes out, but you don't need to calculate 5 times 20, right? You need to be a problem solver. You need to have a desire to do that, right? You want to be a systems thinker. You want to be able to think of bigger picture things. You want to be comfortable with the idea of programming, making recipes and that sort of stuff. Oftentimes we'll call algorithms in data science a cookbook. Go figure. You need to be a good communicator. These two that I'm bringing up right now, communicator and team player, what's really interesting about this is a lot of people go into computer science fields because they want to avoid these things. But at the end of the day, you have to be experts in those things to be in computer science, because you are trying to write in a different language and convey to someone what it does. You have to be a good communicator to do that. To be a good data scientist, you have to also be able to visually communicate or maybe audially communicate, right? The team player business, you can't possibly know everything there is to know about a circumstance you're going to analyze. You need to work with people to be able to do that. People have different specialties. Like I work with spatial data, temporal data all the time. I work with building databases from the ground up. Those are things I do all day, right? Other people are really good programmers. I'm not. I'll be the first to tell you, I'm not a programmer. I teach programming courses. I'm not a programmer. But I know enough to know where my skill set ends its limitation or reaches its limitation, right? And that's important to recognize between people, is that there are skills certain people have. So when I was in grad school, I had this experience of working with an electrical engineer and a marine biologist. We were trying to build an indoor navigation system. And at the end of the day, we were asked what we learned from each other, because we were a cohort doing a graduate program. And what both of my colleagues said about me was they learned from me, they saw that I knew how to deal with positioning something in a way they never could have figured out. Like I was able to piece together different threads that actually solved the problem. But then I said, you know, for the electrical engineer, for instance, that I had no idea how to calibrate the type of thing we were using to run that, but I knew how to deal with the data once we had it. So everybody has different skills. You have to be patient to be a data scientist, because you're going to run into a bunch of brick walls and have to restart certain things. And that's important to recognize that going in, that, you know, a failure in a process is not an ultimate failure. You only ultimately fail when you stop getting up, right? Patient is important. You got to be a lifelong learner. And that's a phrase we throw around a lot. We want our kids to be that, but we have to be that too. Because in the computing fields, what's happening is they're technologically exploding so fast that the things I studied when I'm in grad school are largely irrelevant technologically, right? You have to stay on top of that all the time. Imagine learning Fortran, which is a programming language. Imagine learning Fortran and then all of a sudden it doesn't exist anymore. Like people don't really learn Fortran much anymore. And you have to completely relearn your programming vocabulary, because you didn't learn programming as a language. You learned it as a syntax, right? And the other thing is ethics. We cannot strip philosophy away from data science, because there are so many things happening in the world today that are data-driven that are nasty, absolutely nasty. You have to be a good steward of the situation you are put in, and that requires understanding ethics. In fact, our data science students take a course in computing ethics before they graduate, because it's important, and generally you should be tying ethics to every place in the computing curriculum, and that's an objective I have personally, because you should learn the ethics of the situation while it's fresh in your mind, because it will be one of the first things you think about when you go to do it. So we're nearing the end of this, and I know that I can talk for a while, but I have a thing for Dr. Seuss. Oh, the places you'll go. So Dr. Seuss is actually my fraternity brother, which is kind of fun. But all the places you'll go is going to be sort of an homage to the types of things I've been involved with data over the years. And I don't do this to say, oh, wow, look what this person's done. I do this so that you can see just how diversified the applications of being a data scientist could be. And perhaps it might spark an interest in you. You might see whether or not you could do these things yourself, where you're like, yeah, I really like that, right? I could subscribe to that. Who knew, right? So these are all things that I have been involved with in my career that apply data science principles, and you're going to see all kinds of different things you'd never expect to be here. So first off, the topic of my graduate study would sort of, I'll grab that one. The topic of my graduate studies is actually in spatial reasoning. And essentially what that does is it tries to take maps that could be in a computer and search those maps for things that are common language for us. So things like that something is north of me, or something touches me, or something is contained within this other thing, right? These are all words we use every day. These are the prepositions of our language, the things that relate objects prepositioned to one another, hence the word preposition. These are all types of things that computerized systems can exploit. So I say I'm in the business of making maps talk. And I think that's kind of a fascinating thing. Imagine what you could do with that for somebody who can't actually see the map. How about making government more representative? Who's interested in politics? So I've made a career of developing new measurements for trying to better police the redistricting process in the country so that we get more representative government. So not something you might expect I'd be involved in, but I am. How about understanding how poverty and educational attainment impacts student mindset? So an interesting sort of sidebar about this, I grew up in a community that is very rural, is very poor, and doesn't have a lot of educational attainment. In fact, of all of my aunts and uncles, and I have a lot of them, only one of all of my aunts and uncles and my mom and dad, only one of them has a high school diploma. So this is something that's near and dear to my heart. So I've given presentations to educational organizations here in Maine, and even tried to work with the Federal Department of Education to try to figure out the impacts that these things have on students, and also use the data to leverage where we need to get services. So very much social impact sort of thing. Speaking to that, finding where rural housing insecurity should exist and finding out how to better service that. I have a grad student right now that's working on trying to make a typology of rural homelessness and rural housing insecurity, because that can be for many different types of reasons. The data that we have is all about urban versions of that. It's easier to collect that. So we're trying to do some feature engineering and trying to find, okay, how do these different indicators that are in, say, the American Community Survey relate to some of these principles, and how can we exploit it, put people on the ground and try to see, does the data line up with the experience? We suspect there's housing insecurity here. Is there actually housing insecurity in that location? How about impacts of climate change? So I've been involved with doing modelings of human behaviors and how people accept scientific knowledge. I'm part of an EPSCoR grant that works on leveraging spatial and temporal data to deal with changes in climate. So predominantly agriculture and ecology. But that's some interesting stuff. I've had students work as interns with that grant. So they've done some visualization engineering. They've done some research work with me about formal systems. So that's another broad sort of area people can go into. Leads to things like meteorology and climatology as well. One of the first projects I did in grad school is actually looking at the night sky and trying to find clusters of stars in slices of the sky. So galactic clustering is something I've been involved with. So if you're interested in astronomy, you could find different things there. I had a student once that I worked with doing a multi-level statistical analysis about trying to figure out what types of dogs were more likely to be adopted based on traits of the dog, phenotypic traits of the dog. So we're actually going to start redoing that study here starting this summer. If people want to get involved potentially with a data science project. So he's now a veterinarian. So he wants to get data from all over New England and try to work with their social media outreach campaigns to try to get certain types of dogs adopted that have a harder time, because the marketing campaigns often target certain types of dogs, right? So trying to look at strategies for that, that's kind of fun. What language is that? So I had a student years ago who studied the structure of words. So you think about spelling rules, and you think about if at the end of the word or something like that. And by looking at the patterns in the letters, you could figure out what language something was by conditional probability. So that then has an impact on things like cryptography, trying to bust codes. So the types of codes you try to bust are a lot harder now, but the same premise is involved in that. So I've had students do that. Synthesizing sounds and understanding the human experience of that. So you can go online right now and you can actually generate waveforms of different timbre. So you can literally create your own instruments. But what I get involved with that is specifically looking at the cyclicity of it. Because when you start looking at what's going on here. Yep, I'm on that time frame, Katie. So there's sort of a cyclicity of that. So there's sort of these repeating patterns. One of the things we do in modeling is try to look at the leveraging of those patterns. So what kind of cyclic patterns do we see? So that's an interesting sort of application. I've also worked with students about trying to see, can a human actually detect the difference between harmonic systems? That's fun. Preventing horse injuries. I was part of a massive study about trying to figure out if track conditions, namely the type of surface and the geometry, were responsible for increased rate of injury. It's probably the largest data set I've ever worked with. How should we try to conceive a mare? Should we give a mare a break every now and again in trying to produce foals? So I had a student here at UMA actually work on that. Making buildings more accessible and safer. So this is a professor of mine from grad school, blind. We built a navigation system off of essentially a barcode scanner and RFID tags. So you can see some of those on the wall there. So that's something I've been involved with, is accessibility constraints. Improving manufacturing processes. That's a paper coder. So back when I was an undergrad, I did projects about trying to figure out how well that type of machine was working. That's statistical process control. Understanding perception bias. I've had students work on that idea of thinking about how you perceive yourself versus how you perceive others, and how those things sort of can be disjointed in a sense, and how that might change how you educate someone. Improving executive teams. I facilitate Myers-Briggs analyses for people, and that goes into coaching teams. It also, I do studies for groups that want to understand their operations better. So I get to work with teams to make them function better. I've helped to build chemical sensors to find nasty chemicals like formaldehyde. I've worked on trying to take static maps of flat maps of farms and try to make them 3 dimensions so that you can see, hey, this is where I'm going to have runoff issues, all that sort of stuff. I've done that stuff as well. I've also worked with a grad student who was trying to detect depression by behaviors with someone's phone. So that's also interesting. So I want to thank everybody. Well, wait, actually, no, I've got one more. Cookie cutter documents. So something I've been doing recently is trying to take a bunch of disjointed forms for different stuff and try to make one form that populates them all. So that's related to Mad Libs, if you've ever done something like that. So I've done that as well. And I want to thank everybody for their time and their patience with me through this. I hope it's a good intro to what the field looks like, and I'll stop my sharing because there's, I think, a lot to work with there, and there's something for everybody.
Thanks so much, Matt, for talking with this tonight. It's a lot of information and a lot of great information. I just wanted to open it up for any quick questions that folks might have. Something who's in the chat. I wonder if everyone's just digesting. Maybe something that.
My internet's
we-
been unstable this whole time, so
Oh no.
every time Haley you talk, you kind of go snip, snip, snip.
Uh,
All right, it looks like we have a
And
raised
This happened
hand.
to you as well, Katie.
Oh, shoot, okay. It looks like we've got a raised hand. Did you wanna jump in and ask a question?
Let me leave and I'll come back and see if that solves it for me.
Yeah, I'll wait a moment though. I don't mind.
Okay.
Thank you. If he can't hear us, we can always just drop your question in the chat. And then he'll see it.
Okay.
We should probably let him in. There we go.
Hey,
Hopefully
Matt, is that better?
That's much better.
Oh, awesome.
Yay.
So I
I
have
just
a,
hope people could hear me throughout it because I could not hear a damn thing.
Yes. You only glitched out during like the brain scan piece. So you were,
The breast cell tumors.
oh, there we go. See, there we go. All right, so let's start with the student with the raised hand.
my name's Howard Rowe. How are you guys doing tonight?
Hi, Howard. Great.
I have kind of two questions, honestly. One's a pretty it's a pretty open question. I have Class A felonies. Obviously, I'm in the Maine State Prison right now. How would that affect my employability with these various companies with having I mean, for safety's sake, let's just say I was interested in doing data, a data career.
Mhm.
When these companies, especially like when you touched on the fact that you need to have high ethical values and standards for yourself, well, companies also want to hire someone with high ethic values and standards, and a guy that has multiple felonies doesn't really show his ethics are in line with what a business is looking to hire, if you follow what I'm saying.
I follow what you're saying. So I would distinguish the two. I would say that it may not, and it goes to like correlation stuff, right? So just because somebody has things that are consistent with that, does it mean that they are or aren't? That's a modeling problem. So that's a different thing altogether. But what I would say is that it's going to depend on the company, honestly, because like the federal government, for instance, if you wanted to have a job doing data with the federal government, that's going to have potentially security clearances and that sort of stuff. It's going to be a little different situation than, say, a business that maybe is looking to better leverage resources that they have, right? So that's a difficult question to answer, right? From that perspective, is going to be company to company, or
I figured that.
application.
I just figured with your background and what you do, you would, more so see less hiring of people that have, multiple Class A felonies.
Yeah, so as an educator, which is the type of hiring process I've gone through, that might flag someone as an educator. At the same time, someone who is trying to do work for farms or whatnot, that might not be as big a problem, right? So it's really about what the application is.
My second question was, this course, you did kind of touch base on it, that there's really no major to having major in data science. There's no master in data science. That it's primarily consists of like courses on different avenues of data science branches that one could go into wherever he, kind of like found that it was more what he was looking to do. With that, UMA, what courses with UMA? Because I haven't seen any, I haven't really looked, to be honest with you. what does UMA have to offer in regard to data science?
Well, we have an entire undergraduate major in data science. So that starts off with courses in programming. We'll have a course in introductory data science. So you get the lay of the land of the whole field. You have courses in database design, database querying, data visualization, data mining, statistical quality control, data cleaning, data literacy,
Plenty, basically.
database management. So all kinds of different courses out there, right? So there's and statistics, modeling, there's all kinds of, it's the pieces that go into the career ultimately.
Okay. All right. I was just kind of curious.
That's the lion's share of the data science major. Then there's some math courses, and then there's the outside concentration. So there are a lot of courses that are data sensors. There are a lot of courses that are data courses.
Thank you. I appreciate it.
Yep.
Anybody else have any questions? You can raise your hand or you can just drop them in the chat and we can read them out loud for you. Matt, mine is just kind of for students who might feel intimidated or unsure of their skill set in math, or intimidated and unsure of their abilities to learn what's required in terms of computer skills. But who have an interest in how data and analyzing data might apply to areas that they find interesting, or work that they might want to do in the future. What would kind of be your words of encouragement and your words of wisdom for them, considering tacking on a certificate or a minor in data science?
Okay, so I will say two things as course suggestions. One is, and I would say this to anybody, is that statistics needs to be part of your curriculum, period. I don't care what your major is, statistics needs to be part of your curriculum. That is step one to data science. Step two, I would say, is that there's a course that's an introduction to data science, which will give you an idea. It doesn't ask you to program anything. It will give you an idea of the different types of things that fit around this world. So things like, what is big data? How does that impact the world? What are sensors? How do they work? That sort of thing. What are databases, Internet of Things, data visualization, data mining, stats, you name it. That course in and of itself is meant for that type of student. It's a broader introduction to that whole field. If that's something they want to get into, often it becomes unlearning certain things. It becomes unlearning the idea that I can't program something. Well, some people who think they can't program something actually are experts in foreign languages. And guess what? Programming is thank you, Haley. Yes, and programming is exactly a foreign language. It's the same thought process you go through, and it's just applying languages to solving problems. So that sort of stuff it can be overcome, right? It's just understanding how they sort of fit together. What I will say is that modern technologies have lessened, I think, the need for straight up mathematical prowess. So for instance, if you had told me 10 years ago, somebody's going to be a data scientist, they'd have had to have calculus and be all through, they'd have to do half a math degree, and then they'd have to do most of a computer science degree, and then they got to figure out what to apply it to. Today, with computing languages built the way they are, with things like R and Python that are doing stats like that, what's most important is that you understand conceptually what's happening so that you can then apply it, right? So I couldn't tell you right off the top of my head how linear discriminant analysis works. That's a topic in a data science course. I can obviously tell you how it works, but I'm not going to tell you the math behind it, right? That being said, I'm comfortable enough with knowing exactly what that's trying to do that I know when I should use it or not. And that's the most important thing, right? When you take a data mining course, you're learning how to code in data mining, but you're also learning when that's applicable, right? And that's the most important piece. If you learn nothing else about data, it's about when it's applicable, both the actual stuff you collect and the way in which you analyze it. It's when it's applicable. Because if you don't apply it in the right spots, you're going to have problems. You're going to have problems you don't even know you have because you don't know what it is you're applying, right? That's the piece, is that forget the math. It's literally, what is that trying to do? What does that tell me? Right? That's the most important thing. Now, if you're going to major in data science, it's a different story, right? You're going to need a calc class. You need to understand gradient descent. You're going to need linear algebra. But if you're somebody who wants to see how is that impactful, that's not as important. What's important is what that technique tries to do.
Thank you. Are there any other lingering questions before we wrap up tonight?
I do got one quick question. I'm sorry to hop in with one more, but I was just curious, Matt, what would you say would be the best beginner course for someone looking to get into data science?
Probably CIS 150.
That it, the one that she posted? Okay.
Yeah.
Thank you.
Yeah, it'll give you the biggest scope. So it'd be like what we talked about tonight, but each week would be a different sort of deeper dive into an area. Right? So it'd give you way more than what this would give you.
Okay. Thank you again for your time, and
Yep.
Have a good night.
It looks like we had one more question dropped in the chat. Any suggestions on how to choose a category of jobs to narrow down what type of job to do? It can be overwhelming, I think, looking at all the possibilities that exist with data science and what jobs might be available to someone, say, who is 3/4 of their way through their degree and needing to go back to work, kind of after finishing school, and just, I think, kind of everything we were talking about. So if you have any words of wisdom, please feel free to share.
Yep.
If not, Michelle, what I would say is this is a great one-on-one conversation to have. So maybe being able to book an appointment to start that conversation with Matt and see how you might be able to narrow that down could be a good.
I can give you something briefly here. This goes back to what I said the job market in Maine looks like, right? The job market in Maine, you don't find a lot of job titles, data scientist, stuff like that, right? That is a blessing in this situation because you can find something you're passionate about and say, how can I leverage those types of skills in that environment? Right? So let's say you're passionate about animals. Let's say you're passionate about humane societies. You could get a job at a humane society and you could become quite useful to them if you could help them move their animals, right? So that project I mentioned with the student I had that we're going to revisit, that type of thing, they don't have people working there that can do that. That right there is a place where you can get experiences that you can put down that will say, hey, I've done this. These are the real results this company had by virtue of what we were doing, right? That is a great opportunity, right, in that situation. So if you have something you're really passionate about and you can see how data would work for that, you can find ways to apply it even without the degree yet, right? And then you've fit that other piece of that bill. So that's my suggestion there is rather than looking at the data analyst career, look at the principle of the data analyst career, which is analyzing data, and find places that find things that you're passionate about that are hiring anything, right? And then worry about the degree, if that makes sense.
Yes, I think it does. I also think just in general, and I'm not sure if this fits inside the degree as you have it outlined, Matt, but internships, if you can do an internship to get that hands-on experience, that can be a really great way to decide do I like doing this or do I not like it? Is it what I thought it was or is it not what I thought it was? And just trying to narrow down areas of passion.
That's the fun one here, because the thing that you expect data science to be is not what it becomes when you find yourself having to mess with that data set that somebody has that's really effed up, right? And that situation, that's the one that unnerves sort of the data scientists, because they want to make the conclusions and then you got to realize I got to prep the stuff to be able to do that. So like that's the one that people often really foundationally realize when they do an internship. It's like, oh boy, right? So this is why I mentioned this in a lot of classes. Data cleaning is important, and it's a necessary problem that's going to exist, and you got to be comfortable with that. You got to be comfortable that I'm not going to be making a conclusion every day. Like I'm going to be preparing for it. Remember I said patience was important. This is one reason why. And you learn that one in the internship real fast. So.
Perfect. Any other lingering questions from everyone? Fantastic. Well, thank you all so much for your time, and especially thanks to Matt for being here with us today and taking us through the options and opportunities that exist within data science at UMA for our students. Thank you all and have the best rest of your night. As always, please feel free to email us or reach out if you need any information. We will drop our info in the chat real quick before we hang up.